Hi, good morning, good evening to all of the people joining this webinar. Uh, my name is K K Mookhey, and I am the founder and CEO of Network Intelligence. Quick background about myself and the company. I started Network Intelligence in 2001, pretty much as a one-man show, and now we are a fairly large company with about nearly 600 employees spread across multiple countries. We have operations in the US, Singapore, Dubai, and of course in India. Having said that, let me jump straight into the topic of the day. So I'm going to spend some time with you today just looking at, you know, a lot of the buzz that we're hearing around AI and then its use within our industry of cybersecurity and where it seems to be working and where we seem to be struggling. But before I do that, let me just sort of walk you through a macro view of, generally where things are going, and then how we are truly in the midst of a technology revolution and what that means for cybersecurity. And then we'll get to AI, ML, deep learning, and what its impacts on cybersecurity could be. So, if I ask you to think about this question, when you look at the world at large, do you think it's becoming better or are we becoming worse? Most people in the world tend to answer in the negative. Most of us have a pessimistic view about the world at large. We're optimistic about our individual futures. We think we will do well as individuals, but globally we feel that the world, and that's predominantly because of all the negative news that comes in the media, because obviously positive news doesn't sell, only negative news sells. So there's this very interesting team uh, called the Roslings, who've been doing a lot of research around why we think so negatively about the future. And they have this very interesting site uh, called Gapminder, and it has some very interesting statistics over there. So, for example, this is a statistic about um, life expectancy versus income levels globally. And so, for example, if you go back a few years, let's say we're in the 1970s, and you see how life expectancy actually has been rising, especially see those large two bubbles of India and China, the blue and the red bubbles. And you can see how quickly life expectancy has risen for people across the globe. So basically what that means is that most of us are going to live into our 70s and 80s and beyond, right? So you can see this large bubble where in China life expectancy is 76.9 years, and in India it's about 69 years. So over the last few years it's gone up quite a bit. In the same trend you sort of see in terms of people's income levels. So again, if you take India and China here, where sorry, this is a statistic about babies per women. So people are women are having fewer babies. So what that means is that healthcare is improving. Children are living longer. More children are living through the infant years, and so all of this basically tells us that actually, in many ways, the world is becoming a better place. Average incomes are on the rise, education levels are on the rise, income levels are on the rise. Um, we've managed to defeat a lot of the diseases that we used to be humanity used to be impacted by. So all that is good news. And in terms of, one of the thoughts that people have also is that our population is increasing, the global population. So most, I think the UN and most other organizations agree that population will stabilize around 10 to 12 billion people by the year 2040. So what that I mean, all in all, what this means is that we're living longer, healthier lives, right? So that's sort of the large picture. There are some gray clouds. This is from the World Economic Forum's report, Global Risk Report. And you can see over here that climate change is definitely a major risk according to the WEF. And cyber attacks and data fraud and data theft are also high probability, and in the case of cyber attacks, high probability, high impact risks. So definitely, even from a global perspective, cybersecurity is now a major risk and a major agenda for most organizations and governments across the globe. And also water, we might run out of water. So that's basically where we are. And as I said, probably people who lived in their 20s or 30s, or sorry, people who lived in the 20s, 80s, 90s, probably all of them thought that they are in the midst of a cybersecurity or technology revolution. But I think most of us would agree that definitely we are in the midst of a technology revolution. And that's, we have massive adoption of technology throughout the world. And this technology is becoming extremely pervasive. So, it's becoming very personal. While we have a lot of data that goes out on the mobile devices that we carry, but now we're going to have, a massive uptake in terms of IoT, medical devices, maybe wearable technology will become, wearable clothes will become the norm. So all of this technology is coming really close. All of us, are aware about smart homes and devices that can run our homes for us. And at the enterprise level, there is a massive uptake of technology. So robotics, AI, big data, all of this is changing how businesses operate and what defines the competitive edge for them. Um, and the change pace is also something which is very interesting. So we haven't seen change happen at the pace at which it is happening now. And that's why, many of us or most of us would at some point of time or the other have a feeling of sort of being left behind. And that's not because we are not tech savvy necessarily. It's because it's just the pace of technology change is so massive. Now, for example, if we take banking as one sector, banks are being disrupted massively. Banks have now begun to rise to the challenge. Most of the large global banks run incubation centers to fight technology players who are trying to get into their space. So Facebook, for example, has banking licenses and approvals for financial products across multiple countries in the world. WhatsApp wants to do payments in India. Google has its own mobile payment wallet. Alipay from Alibaba. Ola has its own wallet. So, I mean, they're all sort of, Paytm has launched its own payments bank. So they're all stepping into the traditional bank stuff. And then you have a lot of the pure play fintech startups, the big bazaars and so on and so forth. And they're all going to be competing for our mind share and wallet share. So banks are basically adopting a four-pronged strategy, right? So they're saying, let's innovate internally. So more and more banks are looking at DevOps and containerization and API banking. So they're saying if startups can do this, so can we. And so they're either innovating internally or they're incubating startups. Most banks have incubation centers running, or we partner with those startups, or we simply go out and acquire those startups. So that's sort of where banks are waking up to this challenge, because they also know that any company that comes through with a path-breaking technology could actually disrupt their business models. And their major moat right now for banks is the data that they have of all the customers. So that's one of the key differentiators for them. And as we shall see shortly, even that might not last too long. So again, from an example of one industry, we're looking at a lot of the basic processes have already been automated. There is more automation happening in the basic banking processes. This obviously means faster handling time, lower error rates, and then more advanced processes. For example, credit worthiness appraisal. So if you apply for a loan, it's very likely that there is an automated algorithm to check whether the loan should be given to you or not. And the human analyst or the human banker relies on the final analysis score that this automated algorithm gives him or her. And then banks have also done well in implementing machine learning for fraud detection. So they have built fairly strong algorithms to detect anomalous patterns in your credit card or banking transactions. And so definitely for the advanced process automation, machine learning plays a very important part. And then banks have also moved, in fact, not just banks, many organizations have moved to deploying chatbots. And with technologies like Cortana, you can basically use NLP as a service. And so you as a customer might not know whether you're speaking with an actual human or it's a chatbot that's responding to your queries. And then imagine when this gets added to something like augmented reality and robotics. So you could have, I mean, banks are working towards an almost completely automated branch, like there's not a single human being in that branch. And then the dream for AI in general and any industry is, where the machine can also form judgments and predictions like humans can. So, can machines start imagining the future? And maybe they don't do it the way human beings do it, but if they can do it as effectively for the particular use case or the particular problem statement, that's fine. If their predictions and their models work out better than what a human being can imagine, and they're more accurate more of the time, then you'd rather rely on the machine than a human being to predict, potential NPAs or potential bad loans, for example. Uh, so that's the direction in which most of the AI work within industry might be going towards. But we're not there at the last stage yet. But for the first three, we're definitely there in most industries. For example, even an app like Zomato has a chatbot. It's a food delivery app, and they have a chatbot responding to your concerns and queries. So now, what does all of this imply for cybersecurity? So one, this obviously gives a larger IT landscape for attackers. Almost everybody is adopting the cloud. I mean, not adopting the cloud is now would be seen as a quaint or an archaic mindset. Whether it's only SaaS or it's SaaS and IaaS or it's hybrid cloud. Almost every fintech that we work with is born in the cloud, so they won't even imagine having a data center. And eventually, I think maybe a decade or so down the line, or 2 decades down the line, we'll look back and we'll think, why did organizations even go to the trouble of setting up their own data centers? So cloud computing will definitely become extremely pervasive. And what that means is obviously a larger landscape for attackers to go after. So assets are hosted in environments over which the organization has lesser control. Data flows internally within that environment. You may not be able to manage and control those. And also with IoT, you're just looking at your IT landscape suddenly going up magnitudes of times more. And then industries adopting industrial IoT. So, just imagine the number of IP addresses and assets and asset types and updating and patching and maintaining an asset inventory. I mean, it's going to get pretty crazy. And all of this adds to complexity, right? All of this adds to the entropy of the system. So complexity always makes security more difficult. I have more interconnections, I have more data flows, I have more partners connecting into my network. All of this is going to make security that much more difficult. So things aren't getting simpler. As I said, asset management across IoT, hybrid cloud, One thought that I had was maybe CISOs will wake up one day and throw their hands up in the air and just say, to the hell with building an accurate asset inventory. We'll just see if something gets hacked and then we'll react to it. So and even if you automate asset management and you're able to auto discover and fingerprint your assets and maintain an updated asset inventory, what about patching all of those assets and keeping them updated and hardened, right? That's going to be an even more difficult task, again, with something like IoT in the picture. So asset management is going to become very challenging. A very interesting project that we did was where a customer insurance company wanted to deploy an online chatbot powered by Cortana, and they wanted us to test the security of it. So, one of the set of test cases that we ran was, can we social engineer the chatbot into revealing data for another customer, the insurance policies of some other customer, and so that those are interesting test cases that will come up when we talk about NLP and chatbots. A lot of technology is moving to API based deliveries, microservices. So with the proliferation of these APIs, and each API then becomes an asset, because behind it runs probably a container delivering that microservice. Then you've got to go and make sure that you're securing that asset. And assets can come up and go away, and you will be exposing these APIs to partners and even to competitors. So, for example, you know, HSBC in I think UK has an app where you can see not only your HSBC account information but also for the other banks, because those other banks have created APIs and there's a handoff between HSBC and those banks to share that data. So now through a single app you can see data about all your bank accounts. So all of these APIs are then open for exploitation. And all these integrations will introduce more vulnerabilities. Another interesting aspect that seems to be happening is that, as I mentioned earlier, for banks, a lot of their competitive advantage comes from the massive customer databases that they hold. And so, for example, in Europe, we are seeing regulators moving to a situation where they're saying banks have to share their customer data, of course, with the permission of the customer, with other firms to foster innovation. So they're saying you can't block innovation by holding on to large customer databases, because let's say somebody has a great idea for a machine learning based NPA, bad loan detection system. Now they don't have the data, so they can't even train their algo. They can't improve their algos. And so regulators are saying banks cannot hold on to their customer databases and prevent innovation from happening. So they're going to be forced to share data with others. And if that sort of mindset or that sort of regulatory framework spreads in more parts of the world, it's only going to result in more data being shared. In fact, a very interesting phenomenon is the impact of breaches on the share prices of companies. Most of you would know that the share price of most of the companies, when there's news of a breach, it drops significantly. So whether it's an Equifax or Target or Facebook, Facebook suffered a pretty massive breach this year, right, from their view as feature. But if you go back and look at the share price of these companies, the share prices have bounced back. So what that means is that as customers, maybe we are beginning to care less about the confidentiality of our data, as long as the integrity and availability are managed. So maybe the security paradigm could shift to where confidentiality may no longer be a very important parameter. I mean, organizations might move to a thought process where they might say, yep, so what if our data got compromised? We're still going to be resilient enough and manage the fallout of that breach. Eventually history shows that share prices bounce up. So if share prices bounce up, investors and boards are happy. And so should we really care about protecting confidentiality of data? And then you have medical devices, you have when we had the Mirai botnet, which used thousands and thousands of cameras to create the largest DDoS attack in the world, imagine if the same were done with a network of pacemakers or bionic limbs or bionic implants. So security of medical devices is going to open up a whole new avenue for attackers and for defenders. So in general, what this all means for cybersecurity is that it's going to be a massive business opportunity uh, for at least the next decade or so. So if this is your career option, then it's a great career option to have. And things are going to get really worse before we start seeing things improving. Now let's look at whether AI can have any answers for us in cybersecurity. So let's just do a quick background on AI. So as you all may be aware, Alan Turing created the Turing test, which basically means that if you have an investigator or a tester called C sitting behind a screen, and on the other side of the screen you have two entities, A, which is a machine, and B, which is a human. And C is supposed to ask questions to both A and B and receive responses. And based on the responses, if C cannot differentiate between which one is a computer and which one is the human, then A, which is the computer, has passed the Turing test, which is that for all means and purposes, it is as good as uh, it has replicated human intelligence. So he said, can machines think is a very vague question, but can machines practically replicate human intelligence is probably a better question. So this is the Turing test, and it sort of started, more serious thinking around AI. AI is a concept that goes back actually, probably hundreds of years, and you had philosophers talking about can we replicate human intelligence? Can we create machines or mathematical algorithms that replicate human thought and analysis. And then, of course, once with the invention of computers, the whole thing moved to trying and doing it through computers. And in the 50s, 60s, 70s, this picked up a lot of steam. Then it went through what's called the AI winter, because basically the computing power wasn't there to deliver on what the algorithms seemed to promise, neither in terms of processing nor in terms of storage. So computing limitations basically resulted in nothing coming out from much of that research, and so funding stopped for AI companies in the 70s, and that created the AI winter. And then we went through another cycle. There was another hype cycle in the 80s and 90s. And then again, that with the dot-com bust, again, it sort of went into the cold storage. And then again, now we see so probably the third cycle in AI. But this looks more promising because, thanks to Moore's law, we obviously have much stronger computing prowess at our disposal. We have GPUs, we have much faster storage. Flash is important in terms of data storage and retrieval. So it seems that AI in general will now be here to stay. And with most of the large tech companies delivering so many applications delivered powered by machine learning and deep learning, that we know that self-driving cars, Google search engine, Siri, Alexa, Cortana, this is all examples of AI which have become so commonplace today. Amazon's suggestions on what to buy, all of that is completely AI powered. So just a quick sort of overview on what's AI, what's machine learning, deep learning. So AI, as we know, is more of a concept. It's about the science and the art of replicating human intelligence. And then within AI, there are many approaches to trying and achieving that goal. And machine learning is one of the most popular approaches. So machine learning derives a lot of its capability from mathematical algorithms, statistical models that mine large volumes of data and then discover patterns and are able to then see a new sample of data and then classify or predict what that data represents. So machine learning is one specific approach to AI, and then deep learning is a type of technique within the machine learning family, um, where information is passed through multiple layers, and each layer does further analysis on that data till it passes through the final layer and sort of translates into intelligence at that point. Um, Now, when we look at the implications of AI in cybersecurity, there are some areas where AI has done well or machine learning has done well. We've basically solved the spam detection problem. And I think spam's close cousin, phishing, and possibly business email compromise will also start getting very effectively auto detected by Google and Microsoft on G Suite and O365 respectively. So that's pretty much a clear success case for applications of AI in cybersecurity. Security monitoring, I think we're still not there yet, where machine learning algorithms can detect bad behavior effectively. And so, while we do have a lot of companies that deliver on UABA and NBA, user entity behavior analytics and network behavior analytics, the promise is far from the actual delivery. So, what's happening now and is likely to be the case in the future is that the risk scores from machine learning algos will be one important input in a larger security analytics sort of rule or use case. Um, and that's how it'll proceed. At this stage, in probably wherever we've seen UABA or NBA tools deployed, we cannot move to a situation where we say we blindly rely on the output from the machine learning algo. If we could, then we would probably take that output and then automate the response, because we'd have that level of confidence on the information coming from the ML analysis. But at this stage, I think it's one very important element of the overall security journey, but it's not something that you can bank your security career on. And similarly, on the EDR front, I think progress is being made quite well on using machine learning to detect malware behavior and classify malware based on monitoring their behavior and looking at the millions of, because we have a lot of samples of malware, and so machine learning algos have data to work on. So those are probably in sort of degrees of confidence. Those are the three areas in which AI is actively being used to solve cybersecurity problems. And then in the near term, I also see AI being used to do vulnerability identification, including red team automation. So creating playbooks for red teams, and then tools are now already in place to do adversary simulations. So definitely, there's going to be more spread of AI in vulnerability identification. Will that spread to remediation? At some stage, it will. I don't know if this will happen within the next 12 months. It's easy to make a fool of oneself by predicting timelines around this, but eventually it will happen. Eventually, remediation will be automated through machine learning, because if a machine can learn with a higher degree of confidence when an attack is happening and then go patch that system on the fly, that's better than running a regular patch cycle and patching all my systems. Um, and most organizations fail anyway to do that effectively. So if a machine learning system can do more accurate detection and then on the fly remediation or isolation or whatever is the response in my playbook, um, and it can do it with a higher degree of accuracy and confidence than the human, then definitely remediation will be powered by machine learning. And then a lot of what the chief security officer does. So, for example, Amazon ran a competition on Kaggle.com for using machine learning to automate access control requests and processing of access control requests. So, definitely, that is a possibility where a lot of the decision making or approval process that CISOs have will be automated. Um, So I see that. I mean, I don't think CISOs are going out of a job anytime soon, but a lot of their mundane activities will soon get automated. Um, and so, in general, I see asset management as something that is non-negotiable in terms of getting automated. Definitely, that has to happen. Vulnerability identifications will get automated. Vulnerability remediation will get automated. Incident detection and response detection, of course, is automated. Response is automated to some extent, but not more complex playbooks aren't automated. You will always need human analysts to play a role over there. Security audits might get automated because at the end of the day, it's OCR and NLP and analyzing data and asking static questions and receiving responses and then analyzing that. So a lot of basic security audit work will get automated. So at the end of the day, I think what's very likely to happen, at least in the next year or 2 years, is that more and more of the traditional security tools will start adding machine learning capability as one more element, one more use case or set of use cases within their feature set. Um, but as Gary Kasparov said, the future is not machines versus humans. It's a future where humans learn to work with machines. And I think that applies more true in cybersecurity than in any other case, where human intuition and creativity are so important to detecting and protecting our networks, detecting attacks and protecting our networks from those attacks. But machine learning will become probably one of the most important tools in our arsenal, uh, you know, either from dedicated UABA, NBA type products, um, or from the machine learning capabilities that will get built into even, for example, application security testing tools for fuzzing. Uh, you know, uh, Machine learning will play an important part if the tool can learn from previous tests and then and enhance its test cases as it moves along. So, um, in conclusion, I would say that in conclusion, I would say that machine learning is here to stay. It's extremely important. I think everybody should uh, gain a basic understanding of what this domain is all about. Anybody in cybersecurity should gain a basic understanding of what machine learning is all about. But at the same time, I think we should all be extremely cautious about getting pulled into the hype cycle and believing, some of the vendor pitches that we hear. I don't think that in many of those cases the delivery is where the promises are being made right now. But we'll get there. I mean, if you look at the example of facial recognition, where we used to think that computers will never be able to recognize images, today they can do it in real time across hundreds of people entering into an airport, uh, and detect those faces very accurately. So same with NLP, natural language processing. So all of these technologies are basically getting there, and I think we will see effective usage of machine learning for cybersecurity in the next 12 to 24 months. So with that, that's all I had for today. Any questions? You can put them in the chat. So question from Rahul Khattar, what risk has ML introduced to the landscape? Is it a platform level risk or use of API? I mean, any technology is definitely going to add to the, any system I put into my network is going to increase my IT landscape and therefore my attack surface. Um, if you, if the question is that can that ML solution itself be a target of attack? Yes, but maybe in more creative ways than you think. So, for example, one of the attacks against machine learning technologies is to poison the training data. And if attackers, so for example, if there is a public data set that the machine learning tool is going to use, then you poison that data set. And so when the machine learning algorithm trains on it, it's going to learn the wrong patterns. So that's a nice, interesting attack against a machine learning solution. Um, you know, so that's one. Um, the next question is, any language specific for ML? Yes, R and Python are strongly recommended languages. In fact, most examples or most books that you'll read will end up using, libraries from R and Python for machine learning. So whether it is NumPy or SCI Kit, Science Kit, so those are the two preferred languages. I think probably pick one rather than both. Might be the right approach. All right. So I think those are the questions for today. Thank you very much. I hope you enjoyed the session today, and see you next time.